Hi guys, welcome back. As usual, today we're going to do an amazing science experiment. But it all begins with a question, with the different questions with the same answer. Why do javelin runners always run before they throw their javelin? Why does it take a long time for a train to stop, so they have to put the signal 2 miles away? Let's find out. The answer to those questions was a simple thing in science named inertia. Inertia is also known as Newton's first law. Newton's first law, or the law of inertia, states that if an object is at rest, it will stay at rest. Or if an object is moving, it will stay moving until another force acts on it. For example, take this ball. It is at rest, and it could stay at rest like this for the next 100 years if a force doesn't act on it. In this case, this force is going to be my hand, and I'm going to gently touch it and let it to roll. But then you'll see after a few minutes, the ball stopped. So when I rolled this ball, it actually stopped. But why is that? Newton's law states that if an object is moving, it will keep on moving unless a force acts on it. What force was that? I didn't even touch it. The force was friction. The friction between the surface it was rolling on and the bottom of the ball made the ball to stop. But if I threw the same ball up in the air, the force that would make it come down was gravity. If I threw it so hard, it went to outer space, which would be really cool. There would be no force in outer space, so the ball would stay there forever and ever going. It would stay there moving and moving forever, even millions of years. The ball would not stop because outer space has no force. It has no gravity, it has no friction, and it has no air resistance. In fact, scientists believe an asteroid that hit the Earth and made all the dinosaurs go extinct actually had been traveling in space for millions of years. Now we can start our experiment. I'm going to do two pretty simple experiments. One is to show that if something is at motion, it will stay in motion. And if something is at rest, it will stay at rest. For the first experiment, I'm going to use this spinner. I'm going to spin it and see how long it could stay. It will keep spinning for 2 to 3 minutes because there is no friction. And the only thing that could stop it is the resistance in the air, which little by little will make it to stop. The reason why friction is not stopping it is because the part that is rolling is not touching the surface. For the next one, you will need a cup, a piece of paper, card paper would be good, and 2 quarters. You can set it up by putting the card paper over here and the quarters in the middle of the card paper. But then, when I pull the card out, the card goes, but the coins, they were staying at rest and they want to stay at rest. My impact was on the card, not on the coins. So, they stay there, but then the force of gravity brings them down, like this. Another example is that when you're going in a car, sometimes when somebody puts a sudden brake, your body lunges forward. The reason because of that is inertia. When your car is moving, your body is moving along with it and it wants to keep on going and going and going. But then when they put the sudden brake, your body wants to keep on moving, so it lunges forward. Bye, see you next time. You gotta admit, today's experiment was science-tastic. A fun fact related to today's experiment was that Newton's first law of inertia was actually found before by Galileo, so you could call it Galileo's first law.